directed, weighted, and sparse graphs. These are three different types of graphs. The same graph can have all these three qualities as well. So we are going to learn about directed graphs, weighted graphs, and sparse graphs. We'll take directed graphs first. So any graph that you see can be classified as either directed or undirected. If it is directed, what does it mean? All the edges of that graph will have a direction. That is, A to B will be different from B to A because direction also matters, not just the components. So let us first draw a graph. These are the nodes of your graph. And let us have some edges as well. This graph as of now, this is an undirected graph. So if A, B, C, D, E are my edges, are my vertices, then in this case, there is a connection from A to D, which means there is a relationship from A to D as well as D to A because it is undirected. But the moment I add direction, if each of these edges are directed, then the case would change. In this case, A to D is directed, which means there is a relationship from A to D. But the same is not true from D to A. This is what direction means. And if it is undirected, then this issue is not there. A to D and D to A are all same. Second thing is weighted. So the same way you can classify any graph as directed or undirected, similarly you can also classify as weighted or unweighted graphs. So in case of weighted graphs, each of the edge will have weight. Weight will generally be distance, cost, or something like that. So each of the edges, maybe this is of weight 2, this is of 3, 4, 5, 1 and so on. So the same graph can be directed as well as weighted. Because this graph that I have drawn here, this is directed graph. It is also weighted graph. It is having weights. If there are no weights, that means it is unweighted graph. That is, you just want to show that there is a relationship between one point and the other. When you are adding weight, you are saying this relationship is of value this much, some value 5, 4 or something. So whatever is the weight you are giving, that is the weight of the relationship between those 2 points or those 2 objects. The third thing is about sparse graphs. So what are sparse graphs and dense graphs? So either a graph will be, you can't always say it is either sparse or dense because there is no clear demarcation between sparse and dense. Sparse graph means few edges relative to number of vertices. If you are having some graph like this, if you are having a graph like this, and let us say each edge is related to every other edge, then this is a dense graph. With the same set of edges, if I am having a graph like this is also a graph, but this is a sparse graph. It is called dense when there are a lot of edges in the graph, and it is called sparse if there are very less edges. See, I don't even have to connect all these. See, if I just have some dots, just the vertices, this is also a graph. This is also called a graph. I need not necessarily have edges in the graph. This is still a graph. It is only having vertices. So this is a sparse graph. If I am having one edge, it is still a sparse graph. But if I am having lot of edges, if there are a lot of connections in between, then it is called a dense graph. So now it became a dense graph. So this is between sparse graph and dense graph. So these are all different qualities of the graph. The same graph can have different combinations of these. Same graph can be directed and unweighted and sparse. It can also be undirected, unweighted, dense. All the combinations are possible.